Hi, welcome to this Getting Started with Snowpark for Python with Scikit-learn Quickstart Walkthrough. My name is Mats Stellwall. I work as a field CTO for data science at Snowflake. This Quickstart will cover how to ingest data into Snowflake, a Snowpark data frame introduction, how to do data explorations and data understanding using pandas and Scikit-learn, how to encode and normalize data using Scikit-learn as well, and how to train models with Scikit-learn and Snowpark, and how to deploy those models to run on Snowflake. So let's get started with this by going to the Quickstart webpage. So if you go to quickstart.snowflake.com, you will find a number of tiles containing various Quickstart around different types of subject, how you can use anything from AWS SageMaker with Snowflake to dbt as Snowflake and so on and so forth. Today, I'm going to focus on the new Scikit-learn. So let's search for that by typing in the beginning of it. And we have here a tile called Getting Started with Snowpark for Python with Scikit-learn. So let's start with that. Every Quickstart, as you might know, contains a guide that we're going to use as a basis for running it. This guide contains all the steps we need to go through. It also contains the necessary things we needed in order to do to set everything up in order to run this. We're going to start by verifying. So what you need to have is you do need to have a Snowflake account that you can use. And if you don't have a Snowflake account, you can get the free trial account by clicking on the free trial account link. And it will take you to a page where you fill in your information, and then you can get the Snowflake account created for you. You have to choose what cloud you're going to use, so AWS, Azure, or Google, what region you want it in, and then also what version of Snowflake you're going to use. My recommendation is that you use the enterprise version. Once you have filled everything in and submitted, it will take a couple of minutes, and you will receive an email to the email address you added, where you have a link to activate your account. Once we have done that, we also need to make sure that we have accepted the Anaconda packages, so that we have Anaconda packages enabled in our Snowflake account. The way to do that is to go to our new Snowflake account. Once we are logged in, I need to change my role. So I'm using the org admin role. The way I do that is clicking on my username, going to switch role, and then choose org admin. After that, I go to the admin section and billing and terms. And here I can verify whether if I have acknowledged or someone in my organization has enabled the Anaconda Python packages. If not, I need to do that in order to run this Quickstart. Once we're done with this, we can continue with the setup. The first thing we need to do is to clone the GitHub repository. The easiest way is, of course, to click on the link that takes us to the site. So the Snowflake Labs repository on GitHub, and then we need that there's a specific repository for this Quickstart. I need to clone this or copy the code. So I can either use the Git command line interface. If I'm using GitHub desktop, I can click directly on the code and the down arrow to get that. Or I can download this as a zip file and extract it on my local environment. Another thing we also need to make sure is that we have a Python environment that we can use. If you don't have it, the recommendation is that you download the Anaconda installer from Conda and install that and use that as the basis. Or if you already have a Python environment with Python 3.8, you're actually good to go. We are dependent on a number of libraries in order to run this Quickstart, such as Scikit-learn and, of course, the Snowflake Snowpark Python library. So you need to install the libraries that we have specified here. And the easiest way of doing this is, of course, to copy this and add it to the environment YAML file that we have provided as part of the repository. So let's do that. And I'm going to use Visual Studio Code for this walkthrough. And we actually provide a link so you can go to the site and download it if you don't use it. But you can also use Jupyter Notebook or any other IDE that can run Python. It's up to you. So let me get into my Visual Studio Code environment. I have opened up the new folder that I have. So this is where I have my code from the repository. I'm going to start by opening up my environment YAML file and then just paste the dependencies. I'm going to save this. And then I'm going to open up a new terminal. You can, of course, use the command line if you want to. And I'm just going to go back and grab the command I need to run in order to create the new Python environment that I can use for running this lab. So if I press enter now, it's going to collect my libraries and it's going to install it. This is going to take a couple of minutes. So I suggest you grab a fresh beverage, coffee or something like that, and wait for it to finish. Once the installation is done, we are ready to continue with this. So let's go back to the Quickstart and see what is the next step. The next step is that we need to update the config.py file with our Snowflake account details and credentials. So if I go back, I close my terminal, I can open the config.py file and I can see that there's some information already filled in for me, but there's some information that is missing. So I need to get the account and I need to provide the username and the password. So the user is the user I have for my Snowflake account and the password I created for that. Now, the way how we write the account is we need to provide the organization dash the account name. The easiest way to find that account identifier is to go to your Snowflake account. So we go back to the Snowflake account we have, and down in the left bottom corner, we can see the Snowflake logo, we see the name of our account, and then there's a down arrow that allows us to get the list. This list shows the accounts that we have had access to or the different organization we have been part of. The one that we are using is the one in blue. So if we hover over that, we get a new time that gives us some more information about it. And there we have an icon that enables us to copy the account identifier. So if I click on that, I get the check. I can go back, in my case, to Visual Studio Code, and I can paste that into the account. One important thing to have in mind is that we need to replace the dot with a dash. We can now fill out the rest and save the config file and close it. I'm now ready for the first step, so let us go back to the Quickstart and see what that is. So clicking on the next gives us the first step. So the first step we're going to do is ingesting data into Snowflake. We're going to download the data that we need. We're going to read that into a Pandas data frame. We're going to connect to our Snowflake account, and then we're going to create the database and schema that we need, and then we're going to load this data into a Snowflake table. So let me get back to Visual Studio Code and just do that. So I start by opening the first notebook that is called Snowpark Housing Data Ingest. We start by downloading it. So we have a function in the first cell that actually goes out and pulls back down the data. So this is the California housing data set. It is storing it locally in a specific folder, and it's actually also extracting it from it. The next step I need to go through is to load it into a Pandas data frame. So what this function is doing is reading out in the data that we downloaded in the previous step and adds it into a Pandas data frame. So now it's loading the data into my memory. And I can see I have a number of columns here that we're going to use later on for doing some more data exploration. And we're actually going to build a model using Scikit-learn to predict the median house value for this. I'm now ready to set up my environment in Snowflake. So I'm going to execute this cell in order to connect to my Snowflake account. and creating a database. So if my database doesn't already exist, it's going to create it. It's going to create a schema. It's going to create a warehouse. So warehouse is a compute instance that I'm going to use for this, running in Snowflake. And we can see now that we are using this compute. We're using the new database and the schema. Next step now is just to upload the data into my Snowflake account. So I'm going to use my Snowpark session that we created here. I'm going to use a function that we have that is called write pandas. And what that is doing is taking this pandas data frame that we created here earlier, upload that data into a new table called housing data. I'm saying it is going to auto-create the table. So if the table doesn't exist, it's going to create it. And I'm also saying that it's going to overwrite the table, meaning if the table has data, it will truncate it, or basically it will drop and recreate the table for me. And what it's going to return is a Snowpark data frame that points to that data. And we're going to look into how a Snowpark data frame works in the next step of this. But if I do a dot show, I can see the first 10 row on my data set that I have. Lastly, when I'm done, I'm just going to close my session to my Snowflake account. So let's close this and go back to our Quickstart and see what the next step is. So we now have finished the first data ingestion step. So we have the data we're going to use all throughout the Quickstart now. The next part of this is doing some data exploration. So we're going to connect to a Snowflake account. We're going to compare how a Snowpark data frame works versus a pandas data frame. We're going to use the describe function. We're going to build some visualization. We can actually do some simple transformations as well. So that goes back to Visual Studio Code and open up the second notebook. So this is the notebook that is called Data Exploration and Transformations that we're going to use for this. So I'm going to start off by loading my Snowflake libraries, including my connection information. And then I'm going to connect, once that is done, I'm going to connect to my Snowflake account. So and we also need to verify that we're using the correct Conda environment for this. So if you don't have the Snowpark Scikit-learn, you need to change it as I showed you earlier onto that one. So let's connect to the Snowflake account. And we can see what is the warehouse we're using, which is the one that we created earlier. What is the database and the schema. Now, I'm going to compare a little bit between pandas data frames and Snowpark data frames. So I'm going to recreate my pandas data frame based on the CSV file I have and just verify, for the sake of this, that it actually is a pandas data frame. Secondary, I'm going to create a Snowpark data frame. So that is also using the same data, but since we already loaded the data, I'm going to point it to the table that has that data. So if I execute session.table and provide the table name, I now have a Snowpark data frame that points to the housing data table. The interesting thing here is the biggest difference between a pandas data frame and a Snowpark data frame is where is the data stored. In a pandas data frame, the data is stored in memory in my Python environment. So in my Visual Studio Code environment or in the Python environment I'm running, and we can see that by comparing the memory footprint of these two. So the pandas data frame is using 2.7 megabytes of my memory, and my Snowpark data frame actually doesn't use any of my memory. Well, it might use a couple of bytes, but point being, because why it doesn't use any of my memory is because the data is in Snowflake. So we are not transferring data unless we ask for it. I can convert the Snowpark data frame to a pandas data frame by using the .pandas. And of course, what happens then is we're going to pull back the data from the Snowflake account into memory of the client. So in this case, my Visual Studio environment, and generate the pandas data frame from that. So now I have a pandas data frame from Snowflake. I still have my initial pandas data frame, and if I compare, they are equally the same. As I mentioned before, we can use a .show to take a peek into a Snowpark data frame. And what happens then? Well, we are pulling back data, but we are only pulling back a few number of rows. So the Snowpark data frame points to data in Snowflake, as I mentioned. And when I do a show, we will bring back the 10 first row. And actually the definition of my Snowpark data frame, which I can see by running .queries, is select star from housing data. So a Snowpark data frame is basically generating the SQL needed in order to retrieve data from Snowflake accordingly to what I have done with this data frame. And since I haven't done anything currently, the SQL is select star from my table. When I'm executing .show, Snowflake adds, or Snowpark adds, a limit 10 to this, meaning I'm only interested in the 10 first row that you get back. And as soon as those 10 rows are grabbed, the execution of my query will stop running. So it doesn't really matter if I have 1,000 rows or if I have 100 million rows. The .show will go very quickly because we are only interested in pulling 10 rows as quickly as possible. If I only want to see a couple of these columns, so we looked in the beginning, we have 10 columns in our data frame. I might only be interested to work with 5 of these. There's a couple of ways how I can select specific columns. I can use the .select, provide the list of the columns I want. And in this case, I just want to return a new data frame that contains those columns. Once again, I'm not copying data here. I'm just copying the definition. And if I do a .show on my new, I will see that there's only 5 columns in it versus my original one that has all 10. If I want to use a more Panda-like syntax, I can do that. So I can use the square brackets to define what is the columns I want to return. And you can see I get the same number of columns. I don't necessarily need to get the same result because .show just grabbing the data, the 10 first row. And if I once again take on the new data frame, do .queries, I can see the underlying SQL has changed. So instead of having select star, it now selects specific columns from my table. If I want to add a new column, there's a little bit of difference between how a Pandas data frame works and the Snowpark data frame works. With the Pandas data frame, you can use the square brackets in order to define a new column. With the Snowpark data frame, I need to use the keyword with column in order to create one new column, or I can actually use the keyword with columns in order to create multiple columns at a time. For both of these functions, what I need to provide is the name of my new column and then what is the expression of it. So in this case, I want to add a new column that calculates the ratio between bedrooms and total rooms. And the way I define that is, here's the name. Here's my expression that I'm going to use. So I'm going to take the column called total bedrooms divided by the column called total rooms. And I'm going to return a new data frame for that. And then if I now do a .show to peek in it, I can see the ratio between the total rooms and the total bedrooms and the total rooms. And once again, if I look at the queries for this, it is just generating SQL. So this is the SQL that is needed to execute in Snowflake in order to retrieve the data accordingly. Now, we saw how we can select specific columns, but let's say in the case where we have a lot of columns and we don't want to select the ones we have, we just want to drop the ones we're not interested in. So if I have 100 columns and I want to keep 98 of these, so 99 of those, I don't want to specify all 99, I just want to specify the one that I want to get rid of. So a Snowpark data frame has the method called drop, where I can provide the column names that I'm interested in removing from the output. So if I use that on my new column to say drop, and then look at the result, well, now the columns is gone from the result. If I want to filter out rows, so if I want to select specific rows, you need to use the filter or the where clause for that. So in this example, if I'm interested in looking at the rows where the ocean proximity is either inland, Iceland, Island, or near bay, I can use the filter. I can specify the column I want. I can say, in this case, I do a dot in underscore, and the reasoning for it's an underscore is because Python also has an in function, and we don't want to overload that or confuse that. And if I do a dot show now, I will see, well, I will still see nearby because these are the first that it gets. But if I look at what happens behind the scenes, if I take my data frame, take filter, and then just look at the queries and execute that, I can see that it now has added this filtering to my SQL that is executed in Snowflake. We can also aggregate the data. So I have now filtered my data frame to only return inland, Iceland, or nearby. Let's say I'm interested to count the average number of households for each and every of these values. I can do that by using the dot group by. So I want to group by ocean proximity, and then I'm interested in aggregating. So I want to do a calculation or a summarizing, and then I'm in that aggregation function. I provide the different aggregations I want to do. So in this case, I only want to do one thing. I want to do an average household, and then I have an as underscore, which means this is the name I want to give the output of this. So if I do a dot show on it, we can now see for each one of these we have filtered out. I can see the average number of households for them. We can sort the data, obviously. So using the dot sort gives us the control over how we're going to see the data. And if I do that, we can see now it has changed a little bit. Well, not changed so much. So let's change it to ascending instead and execute. And then we can see that the data is now sorted differently than it was before. So let's do some data processing and let's use Scikit-learn for this. However, before I start, I can actually use some functionality in Snowpark for that as well. So I just want to get an understanding of my numeric and character columns. I can use a dot describe on my Snowpark data frame. And since all these methods and functions usually return a new data frame, I need to have it changing the whole thing to add dot show in order to see the result. The describe gives me basic statistics about my numeric and character columns in my based on my data frame. So I will get the count, the mean, the standard derivation, the minimum, and the maximum. The nice thing I think about this is, for example, the count is giving me the number of rows that has a value. So I can quickly scan through and see, for example, that total bedrooms seems to have missing values because they are fewer than the number of rows we have in total. I also know that the minimum and maximum is based on only on those rows that has values there. So what I can see, as I said, that the total bedrooms are missing. So let's continue to work a little bit with that. One thing I want to do, and I'm going to use this later on when I'm doing visualizations, is I'm going to pick up, create a list of all my numeric columns. So what I'm doing is we are specifying the data types for numeric columns. So the Snowflake data frame has their own data types for each and every column that is based on the Snowflake data types. So we have decimal type, long type, double type, float type, and so on and so forth. So I'm just creating a list of numeric types, and then I'm filtering out. So every data frame has a schema, and the schema has fields where each one of these has a data type. So I can now get my numeric columns, and the same thing I want to do for my string columns or my categorical columns, where I just say, give me everything of string type, and I have that in a separate list. And I'm going to use this a little bit later on, so bear with me there. If I want to impute values, I can do this in multiple ways. I can actually manually impute them. I can use Snowpark has a function for this that is called fill NA that enables me to specify a value to replace missing values for. However, since we said that this quick start is about Scikit-learn, I'm going to show how we can use Scikit-learn for this. The first thing I need to do in order to apply this to the data is obviously I need to convert the Snowpark data frame into an object type that can be used by Scikit-learn, since today Scikit-learn doesn't support Snowpark data frames. So I'm going to do it to pandas to pull back my data into a pandas data frame. And then I'm going to create a simple imputer that is using the mean strategy to replace missing values. And we define missing values as none. I will fit that on my total bedrooms, and then I will apply that against on my pandas data frame. So this is how I could do this simply. Obviously, when I do this, I actually have pulled out the data from Snowflake, so my pandas data frame is completely disconnected. Everything is happening in memory. So I need to think a little bit about how I do this since I'm pulling out data. In this case, it's not that much data, so it's not that bad. But let's say I've had 100 million rows. Maybe this wasn't that good idea. And we're going to look at this in the next step of the quick start, how we can work around this a little bit. And if I just look at the count of bedrooms, I can see now everyone has a value. In the same sense, we can use, for example, the pre-processing normalizer on some of our numeric columns, the same way we do with any pandas data frame with Scikit-learn. There's no specific in this case, because now we're using a pandas data frame. Obviously, if we want to store this data in Snowflake, we need to do a write pandas again in order to get it there. I can do some visualization as well if I want to see how we divide a little bit around the median house value and so on to see where we have the biggest values. We can also plot a histogram of all our continuous values to see the distributions of those. And once again, since Snowpark today doesn't have visualization capabilities, I need to use a third-party library for that. And the easiest way is obviously to convert my Snowpark data frame to a pandas data frame and using pandas built-in visualization. So I can see how my longitude and latitude, maybe that is not so interesting to look in because it's coordinate. But the housing median age, how that is distributed, the number of rooms, bedrooms, population, income, and so on and so forth. We can also look at the correlation to see if there's something interesting here. So using, once again, converting it to pandas to use the correlation function of pandas in order to create the heat map using Seaborn. We can look at there's some obviously relationships between latitude and longitude, which would be very obvious in this. But we also have some interesting between population and total bedrooms, population and total rooms. And that makes also sense because the more people live in an area, well, the more rooms we need in that sense. We can also see that there's not a very strong, but a fairly strong correlation between median house value and median income. And that maybe makes sense as well, that the more you earn, the more expensive houses you can buy. So this concludes this step. I'm just going to close my connection to Snowflake, and I'm going to go back to the quick start to look at what we're going to do next. So the next part of this is to start doing some machine learning. So once again, we're going to connect to Snowflake using Snowpark. We're going to work a bit with the Snowpark tables. We're going to create a stage, so a storage area where we can store our model. And then we're going to actually generate the training function that we're going to use in Snowflake to train there instead of pulling back the data locally and run at that. And in the last, we're going to create a Python user-defined function to do the inference of new data with the trained model. So let's go back to Visual Studio Code and see how that can look. And I'm going to open up the last notebook for this. And we're going to run it. So we're going to train, we're going to use imputations, and we're going to do some scaling and one-hot encoding. We're also going to train a random forest regression model on this. First thing first, I'm going to load the libraries that we're going to use. So we can see we are using the Snowpark library. We're using a number of parts of the Scikit-learn, sklearn libraries. I'm loading my configuration, and then I'm just connecting to my Snowflake account so I can work with the data there. The first thing I'm going to do here is I'm going to create a stage. So what is a stage in Snowflake? A stage is a pointer to storage. Now, this storage can be cloud storage, and that can be in AWS, in Azure, or Google. It can be internal storage. So what we call an internal stage, it's storage that is part of your Snowflake account and managed by Snowflake. It can actually also be on-premise storage. So if you have a storage provider on-premise that follows the AWS S3 compatible API, you can actually map that up from Snowflake. What we're going to create here in the first step, if I run this, is an internal stage in Snowflake called the QS Scikit-learn stage. And we're going to use that to store the code for our store procedure and user define, as well as the model file that we're going to generate. And that when it comes to storing code that is used by a store procedure or a user defined function, we do need to use an internal stage. Next, I'm going to create a function to fit a pipeline. So what I'm having here is I'm defining a pipeline that is going to use the simple imputer with the strategy median and the standard scalar on my numerics. I'm going to also use a simple imputer on my categorical variables where I'm using the most frequent. Then I'm going to use a one-hot encoder as on it. I'm going to combine that with a column transformer so I can just provide the input which is in my numerical attributes and my categorical attributes. Use that as my preprocessor, and once that is done, I'm going to train a random forest regressor using 100 estimators. I'm setting up a random state, so I basically get the same model every time I run it with the same data. I'm also setting number of jobs equal -1. That tells that I want to use every available core I can get, or as many threads I can get when I'm running this training. So let's define this function. And let's test this function locally before I use it in Snowflake. So what I'm going to do here is I'm actually going to pull data from my Snowflake account. So I'm going to create a data frame that points to my housing data. But before I pull back the data, I'm going to sample out 10% of the data and take those 10% and generate a pandas data frame. Now, I can also, instead of say a fraction, I can also say number. So let's say if I had 100 million rows table, 10% might be too much. So I might have specified to say, give me back 1,000 rows or 10,000 rows. But in this case, 10% is not that much. So we can see if I download this, it will generate about 2,000 rows for me. Then I'm just going to set up my X and Ys. I'm going to define what is my numericals, what is my categorical, and then I will run this pipeline. So now I see I have a fitted pipeline with my preprocessors and my random forest. And if I run it on my data, I get the prediction back. So far, everything is good. Now I want to run this on the full data set. So I want to run this in Snowflake. In order to run Python scripts in Snowflake, we need to create a Python store procedure. The Python store procedure is basically a way for us to run a Python script. What it needs a function. So it needs to have a handler it can call. So I do need to create a function for it. I could provide this function if I modify it, but I'm going to create an additional function for this. I'm also going to create a helper function that allows me to save my trained model, or actually save my fitted pipeline to a Snowflake stage. And the stage name is something I provide, and as well as the file name and the path. So I'm just creating a helper function for saving files to a Snowflake stage. And then I'm creating the primary store procedure. So the primary Python function that I'm going to deploy into Snowflake as a store procedure. Now, the function needs, the first parameter of this function needs to be a Snowpark session object. This is because when I run this in Snowflake, Snowflake will handle the authentication for me. And based on that, it will create a Snowpark session object and provide that as an input. So I can take that and use that for the rest of the execution of this. Then I'm just going to provide the training table, the target column, and where I'm going to save the model. This store procedure will return a dictionary, so I can add some values to that and return to the caller. I'm starting off by getting the table, a data frame that points to my training table. I'm using a Snowpark data frame function called random split. So I can get 80-20 into my training data versus my testing data. I'm using a seed, so we get the split repeatable. Then I'm pulling out what is my categorical attributes, my numerical, and so I can have that. I'm just setting up some unique names because I want to save the training data and the test data as persistent in Snowflake, so I can go back and look what was the data I was using. So I'm just using Snowpark to write back my training data and my test data to these new tables. And then I'm pulling it back with two pandas. The difference is when I'm using two pandas now versus when I did it before is I'm not pulling back the data to my client. I'm pulling it back to the compute where the store procedure is running. So this is an important thing to have in mind. The data will still not leave Snowflake. It still is within the Snowflake environment, but it goes from the Snowflake storage into the memory of the store procedure. I'm calling my training function. I'm saving the trained model to my stage. I'm just creating a unique path using the date and time. I then get the test data. I get some, but I'm only getting the mean square error. And then I'm creating a dictionary that I can be used to provide some return values. So what was the MSE, the RMSE, where is the model saved, what is the name of the training table and test table. Once I've done this, I can deploy this into Snowflake. So what I'm doing now when I'm running this sproc function is I'm taking this function and all the function is dependent on, so including this one and including this one. What it will do, it will generate Python bytecode of that. It will upload that bytecode to the stage that we created earlier. So the stage name we had there. It will also verify the libraries I want to use. So I need to provide what is the third party, what is the libraries from the Snowflake Anaconda channel that I'm dependent on to run this. So in this case, I need to use the Snowpark for Python, Scikit-learn, Pandas, and NumPy, and some others. Once I have done that, I can actually now execute my store procedure. So what this is doing is it returns a callable object. That means I can use that callable object in my Python session to trigger it on Snowflake. What happens behind the scenes is Snowpark is generating a SQL, which is basically call my store procedure name, train house SP, and that is executing it on Snowflake. And once it's done with the training, it will return the data to me. That means I can actually trigger this training store procedure without using Python. I can do this with any SQL that can run against Snowflake. Meaning I'm not dependent on Python in order to run training using Python. I think this is a pretty cool thing that we can do. The first time I run this, it's going to take me approximately a minute, so we can see 57 seconds. And what I get back is my MSE, my RMSE, where did I store my model, and what is the name of my training and testing tables. Now, as I mentioned, is this training, once I do two pandas, it's running on the compute, in the compute memory. There's a limit amount of memory. So if I'm using huge volumes of data, so gigabytes of data or terabytes of data, I can use something that is called the Snowpark optimized warehouse. This allows me to get access to more memory and more cores in order to run that. And we have provided you with an example how you can create this type of warehouse and run the store procedure with it. I don't need to change anything in the store procedure because it's only different compute. In this case, I'm not going to run it. I'm just going to check that we actually have a model stored in the stage we created. So you can actually list files in any Snowflake stage by each in the SQL called ls and stage name. And we can see that this is the model or the fitted pipeline we trained. And actually this zip file contains the code for the store procedure. So I'm ready to deploy this. Let's say I'm happy with the values I got, my metrics, and now I want to run this on Snowflake data. So I want to use this fitted pipeline or this fitted model. what I'm going to do is I'm going to create a user-defined function. So user-defined function is a way for me to create functionality in Python and apply that on data. So think of it like when you are using a specific NumPy function, or if you it's equal to that, or equal to using a pandas function. So pandas get dummies or pandas something else. That is what is a UDF is. So think of it that there's something that I want to run on the data I have in my data frame. I'm going to create a helper function for this. So I'm going to create a read file that allows me to load the model file from the Snowflake stage. So the model file that we created earlier, I want to load that file into memory, use that in my user-defined function. I'm using the cache tool in order to only run this once. So the first time it's called, it's going to load the file from the stage, but it's going to cache the result in memory. So the next time I'm running this, it will just return the cache value. Then I'm going to create the actual user-defined function. So I'm defining what the names of my feature is, and then I'm using the UDF decorator. I'm giving the user-defined function a value, a name, telling if it's permanent or not. Where is the location of the code? Where it should put its code? If it's going to replace, what is the import is pointing to my model. So I'm telling it that I want to have access to this file. That is what the import does, and that is what I'm using this function for. And then I'm just saying what is the third-party Python libraries I need to use. I'm defining this that I want to have a pandas data frame as an input with a number of columns, and I'm going to return a pandas area. This means that this function will get the batches of rows every time it's called. The nice thing with how Snowflake executes UDFs is that we actually distribute them among the cluster, the compute cluster we're running. So we usually run multiple versions of the same UDF, and we run it in parallel. So Snowflake divides up how the work it's going to do and how it's going to run and collect the data, which means we're going to run multiple versions of this function. However, by default, we call this function one time for every row. So since it's running in a Python environment, it creates some latency. A way for us to get around this is to say, I'm not interested in getting a call for every row. I'm interested in getting a call for every n number of rows. So by using a pandas data frame as an input, I'm telling Snowflake, instead of calling me for every row, call me for a number of rows. So what I get is a data frame with a batch of rows that I can apply at the time, which means it's going to run much faster for me. That also means I need to return my predictions as a pandas series. So if this is a list, we will automatically convert it into rows that comes back. So if I want to test it, I can use Snowpark for doing that. So we have our Snowpark data frame. I'm just saying I want to call my function, and I provide my inputs, and the return is going to call prediction. And then I'm just adding the median house value as an actual label so I can easily compare. The cool thing is, and I think this is really cool, is a user-defined function. So this function I created, I don't need to, I can call it from Snowpark using Snowpark for Python, but I can equally call it from Snowpark for Java or Scala, or I can call it with SQL. That means any tools that can use any of these languages can use my model. It also means that my Java and Scala programmers can use the same model or any other UDF I create with functionality. So we can share logic between languages in a very easy way by using user-defined functions and stored procedures. I think that is a really awesome thing. And by that, we have concluded the Quickstart. So I'm going to turn off my, shut down my session to Snowflake, and just going back to the Quickstart page. So we have done the end-to-end machine learning. And by that, we have concluded the old Quickstart. So we have looked at how we can ingest data in Snowflake, how we can do data exploration and data understanding, the difference between a pandas data frame and Snowpark data frame. We have done some encoding and normalizing. We have looked how you can train a model with Scikit-learn. in Snowflake using Python stored procedures, and also how you can deploy that model into Snowflake using user-defined functions to do inferring. I do hope you find this valuable, and I do encourage you to test out some of the other quick starts that we have on this page. It's a ton of them. It's cover different types of topics. And with that, I will thank you for watching and wish you a pleasant day. Thank you.